Dear students, in previous class we have discussed about joint probability. In that, marginal distribution and covariance, mean or expectation of x, expectation of y, marginal distribution of x, marginal distribution of y, and covariance and all, right. Now let us move to some more examples based on that concept only. Now here, the first problem. Suppose x and y are independent random variables with the following respective distributions. They have already given the marginal distributions. Find the joint distribution of capital X and Y. Also verify that covariance of xy equal to 0. Now, they have given xi as well as f of xi, that is 1, 2 and 0.7, 0.3 given. And what about yj? Yj is minus 2, 5, 8. Gyj is 0.3, 0.5 and 0.2. So, they have given x values as well as corresponding fx values, y values and corresponding gy values. Now, that means they have given already the marginal distribution table. We need to find the joint probability distribution. How to find the joint probability distribution? See here, since x and y are independent, the joint distribution j of xy is obtained by what? What is the formula? That is jij equal to fxi into gyj, right? Fxi into gyj gives jij. That means fx1 into gy1, that gives j11. Similarly, fx1 gy2 means j12. fx1 gy3 means j13 and so on. Similarly, here 2, here 1 means j21. Here 2, here 2 means j22. Similarly, fx2 and gy3 means j23. So like that you have to compute. Now, here jij are obtained on multiplication of the marginal entries. So the given data and the required jij is exhibited in the following table. So what are those x values? 1 and 2, that is x1 and x2 only, but y values takes 3 values, that is y1, y2, y3. What are x1, x2? 1 and 2, y1 minus 2, y2 is 5, y3 is 8. See here they have given these are the x values and these are the y values. And what is fx1? fx1 is 0.7, gy1 is 0.3, fx2 is 0.3, gy2 is 0.5 and there is no fx3 here. Here gy3 is there, 0.2. Now just you need to apply it in the standard formula. So what is j11? See here, first row, first column j11, first row, second column j12, first row, third column j13. Similarly, second row, first column j21, second row, second column j22, second row, third column j23. And what are those values here? fxi, because xi given row wise, so here also I will write fxi. And gyj column wise, so here gyj means what are the values given here? 0.7, 0.3 are fxi values, 0.3, 0.5, 0.2 are gyj values. And you have to check whether if you add this, you should get the same 1. Answer is 1. See, 0.7 plus 0.3 is 1.0. Similarly, 0.3 plus 0.5 plus 0.2 is again 1.0. Now, so this is the marginal distribution condition, right? What is J11? fx1 into gy1, right? So 0.7 into 0.3. Similarly, j12 means 0.7 into 0.5. j13 means 0.7 into 0.2. What is j21? j21 means what? fx2 into gy1, that is what? 0.3 into 0.3. j22 means 0.3 into 0.5. j23 means 0.2 into 0.3. So that is what we will get here. See, j11 is 0.7 into 0.3, that is 0.21. j12 is 0.7 into 0.5, that is 0.35. j13 is nothing but 0.7 into 0.2, that is 0.14. j21 is 0.3 into 0.3, 0.09. j22 is 0.3 into 0.5, that is 0.15. And j23 is 0.3 into 0.2, that is 0.06. Now the joint distribution table is what? X and y. Here x values are 1, 2, y values are minus 2, 5, 8. And gyj values here 0.3, 0.5, 0.2, that already we have discussed. And fx L values are so 0.7 and 0.3. If you add, you will get 1. That also we have already discussed. Now, you have to write the first row, first column element as j11, that is 0.21. Next, j12 is 0.35, j13 is 0.14. Similarly, j21 is 0.09, j22 is 0.15, and j23 is 0.06, right? So this itself is the joint probability distribution of x and y. Okay, now how to find the covariance? Covariance of xy is nothing but E of xy minus Ex into Ey, or mu x into mu y. One at the same. E of xy is nothing but expectation of xy. Even mu x is nothing but expectation of x, E of x. Mu y is nothing but expectation of y, that is E of y. What is E of x? We know summation xi into fxi, right? But what is xi into fxi? See here. X is nothing but 1, fx is nothing but 0.7, x is nothing but 2, fx is nothing but 0.3. So what is E of x? 1 into 0.7 plus 2 into 0.6. That is what? 0.7 plus 0.6, that is 1.3 you will get, right? Now similarly, what is E of y or mu y? Summation yj gyj. That is what? Yj into gyj. What are the y values? Minus 2. 5, 8. Gyj value is this one. So minus 2 into 0.3 plus 5 into 0.5 plus 8 into 0.2. What you will get? Minus 0.6 plus 2.5 plus 1.6. So finally we will get 3.5 is the answer, right? So this is E of x and E of y. Now let us move to the expectation of xy part. What is E of xy? That is summation xi yj into jij, right? That is nothing but x1 y1 into j11 plus x1 y2 into j12 plus x1 y3 into j13. Similarly, x2 y1 into j21 plus x2 y2 into j22 plus x2 y3 into j23. Up to how many I and j is present, that much you have to compute. Okay. Now here 1 into minus 2 into 0.21 plus 1 into 5 into 0.35 plus 1 into 8 into 0.14 plus 2 into minus 2 into 0.09 plus 2 into 5 into 0.15 plus 2 into 8 into 0.06. After computation of this, you will get minus 0.42 plus 1.75 plus 1.12 minus 0.36 plus 1.5 plus 1, here 0.96. Finally, we will get 4.55. But what is covariance of xy? We have the formula E of xy minus Ex into Ey. Just replace here 4.55 minus, here E of x is what? 1.3 we have done here, see, and into E of y is 3.5. Just replace back here, you will get equal to 0. So here from this result what we can prove? If covariance of xy equal to 0, that means the for independent random variable x and y are verified, right? Now next concept, suppose x and y are independent random variables. Here x takes the values 2, 5, 7 with probability 1 by 2, 1 by 4, 1 by 4 respectively, and y takes the values 3, 4, 5 with the probability 1 by 3, 1 by 3, 1 by 3. Now first problem, find the joint probability distribution of x and y. Second one, show that the covariance of x and y is equal to 0. Third one, find the probability distribution of z equal to x plus y. Okay, now here we have to write the given data in the form of the marginal distribution. What is the marginal distribution for this? X represent 2, 5, 7. Write in x row. And what are fxy values? 1 by 2, 1 by 4, 1 by 4, right? Similarly, yj 3, 4, 5. And what is gyj? That is 1 by 3, 1 by 3, 1 by 3. Now, after mentioning the marginal distribution, you need to write its joint probability distribution. That is jij equal to fxi into gyj, right? Where I and j both are same, 1, 2, 3. So here j11, j12, j13, j21, j22, j23, j31, j32, j33 you can find. Now how to find j11, j12 and all? First row, first column. See here fx1, gy1. So this is j11, 1 by 2 into 1 by 3, that is 1 by 6. Similarly, j12 means fx1 into gy2, that is again 1 by 6. Again, what is j13? fx1 into gy3, right? That is what you will get, again 1 by 6. So j11 also 1 by 6, J12 also 1 by 6, J13 also 1 by 6. And what is J21? That is fx2 gy1, and this is fx2 gy2, this is fx2 gy3. See here, just multiply, what you will get, fx2 this one. So 1 by 12, again 1 by 12, again 1 by 12. Similarly, what is, see, 1 by 12, 1 by 12, 1 by 12. Similarly, what is J13, sorry, J31, J32, J33? That is fx3 into gy1, fx3 into gy2, fx3 into gy3. So 1 by 4 into 1 by 3, 1 by 4 into 1 by 3, 1 by 4 into 1 by 3. So 1 by 12, 1 by 12, 1 by 12 we will get. Add row wise and column wise. What you will get? 1 by 6 plus 1 by 6 plus 1 by 6, that means 3 by 6, that is 1 by 2. 1 by 12 plus 1 by 12 plus 1 by 12, again 3 by 12, that is 1 by 4. Again 1 by 12 plus 1 by 12 plus 1 by 12, 3 by 12, that is 1 by 4. Now if you add column wise also, 1 by 6 plus 1 by 12 plus 1 by 12. So 1 by 12 plus 1 by 12 means what? 2 by 12. 2 by 12 means what? 1 by 6. 1 by 6 plus 1 by 6 means what? 2 by 6, that is 1 by 3. Similarly, here also 1 by 3, here also 1 by 3. But at the end, if you add row wise, its sum should be 1. And at the end, if you add the column wise also, it should be 1. So 1 by 2 plus 1 by 4 plus 1 by 4, that is 2 by 4 means 1 by 2. 1 by 2 plus 1 by 2, that is 1. Again 1 by 3 plus 1 by 3 plus 1 by 3 means 3 by 3. Again it is equal to 1. So this is the joint probability distribution table. Now let us covariance of xy, that is exy minus mu x into mu y, right? Now here we need to find E of x, expectation of x, or mu x1 at the same, that is summation xi into f of xi, right? That is we need to find the sum of the products of what? X into fx. So what we will get? 2 into 1 by 2 plus 5 into 1 by 4 plus 7 into 1 by 4. What you will get? See here, 5 into 1 by 4 plus 7 into 1 by 4 means 12 by 4, that is 3. 3 plus 2 by 1, 2 into 1 by 2 means 1 here. 3 plus 1, that is 4. Similarly, find expectation of y or mu y. That is nothing but summation yj into gyj. That is 3 into 1 by 3 plus 4 into 1 by 3 plus 5 into 1 by 3. So what we will get? 4 into 1 by 3 plus 5 into 1 by 3 means 9 by 3. 9 by 3 means 3. 3 plus 3 into 1 by 3 means 1 here. So 3 plus 1, that is 4. Now similarly find EXY. EXY is nothing but what? Summation xi yj into jij. That is x1 y1 into j11 plus x1 y2 into j12 plus x1 y3 into j13. Similarly x2 y1 into j21 plus x2 y2 into j22 plus x2 y3 into j23. Similarly one more is there, because I is also 1 to 3, j is also from 1 to 3 here. So x3 y1 j31 plus x3 y2 j32 plus x3 y3 j33. So here what we will get? 2 into 3 into 1 by 6. So here 1. Similarly here 2 into 4 divided by 6, that means 4 by 3 plus 2 into 5 into 1 by 6, that means 1 by 3 into 5, that is 5 by 3. Next here we need to check for this. 5 into 3 into 1 by 12, that is 5 by 4. Next 5 into 4 into 1 by 12 means 5 by 3. 5 into 5, 25 by 12. Next plus 7 into 3 into 1 by 12, that means 7 by 4. 7 into 4 into 1 by 12 means 7 by 3 plus 7 into 5 into 1 by 12. Now simplify it, you will get 16. Now substitute back in this formula. What is covariance of xy? E of xy minus mu x into mu y. 16 minus 4 into 4. So what will get? 0, right? 16 minus 16, 0. Now at the end what we need to calculate? If z equal to x plus y, then what is the probability distribution? Now they have given already z equal to x plus y. That means zi means xi plus yj or whatever yi. Now here what you will get? Add all x plus y. Just add. What you will get? See, 2 plus 3 is 5. 2 plus 4 is 6. 2 plus 5 is 7. Similarly 5 plus 3 is 8. 5 plus 4 is 9. 5 plus 5 is 10. Next, 7 plus 3 is 10. 7 plus 4 is 11. 7 plus 5 is 12. So what you will get? We will get from 5 to 12 continuous. 5, 6, 7, 8, 9, 10, 11, 12. Now, here what is the probability distribution, corresponding probability distribution? Now let us add this one. So what you will get? Xi plus yi. So that what will get here? See, 1 by 2 plus 1 by 3. Similarly 1 by 2 plus 1 by 3. 1 by 2 plus 1 by 3. Same here. 1 by 4 plus 1 by 3. 1 by 4 plus 1 by 3. 1 by 4 plus 1 by 3. Even next also same. So what you will get? 1 by 2 plus 1 by 3 means what is the LCM? 6 is the LCM. Now simplify, that is you will get like this 1 by 6, 1 by 6, 1 by 6. Similarly for this 1 by 12, 1 by 12. See here everything we have given, right? If you add, what you will get at the end? You should get equal to 1. Then only the probability distribution is proper. See here, add 1 by 6 plus 1 by 6 plus 1 by 6. That means 3 by 6. 3 by 6 means 1 by 2. Similarly, 1 by 12 plus 1 by 12 means 2 by 12. That means again 1 by 6. Plus 1 by 6. Again 2 by 6. That means 1 by 3. Next again 1 by 12 plus 1 by 12. So if you add all, you will get equal to 1. So the given probability distribution is proper one, right? Next, see here, given the following joint distribution of the random variables x and y, find the corresponding marginal distribution. Also compute the covariance and the correlation of the random variables x and y. Here x values are 2, 4, 6, y values are 1, 3, 9. Now 1 by 8, 1 by 24, 1 by 12, 1 by 4, 1 by 4, 0, 1 by 8, 1 by 24, 1 by 12. So here first you have to compute marginal distribution of x and marginal distribution of y separately. What is the marginal distribution of x here? X values are 2, 4, 6, see here. Y values are 1, 3, 9. Now, what is the marginal distribution of x for 2? 1 by 8 plus 1 by 24 plus 1 by 12. So, simplify here. If you take the LCM, what you will get? 1 by 8 plus 1 by 24 means 4 by 24 plus 1 by 12. That is what? 1 by 4. Similarly, for 4, 1 by 4 plus 1 by 4 plus 0. That is 2 by 4. That is 1 by 2. Again, for 6, 1 by 8 plus 1 by 24 plus 1 by 12. Again, 1 by 4. So, if you add, you will get 1, right? See, 1 by 4 plus 1 by 2 plus 1 by 4 means, so 1 by 2 plus this is 1 by 2. So finally you will get here 1. So the marginal distribution is proper. Similarly, compute it for y 1, 3, 9. So column wise add 1 by 8 plus 1 by 4 plus 1 by 8. So here what? 2 by 8 means 1 by 4. 1 by 4 plus 1 by 4 means 2 by 4, that is 1 by 2. Similarly, 1 by 24 plus 1 by 4 plus 1 by 24, 1 by 3. So 1 by 12 plus 1 by 12, that means 2 by 12, that is 1 by 6. So these are the marginal distribution of x and marginal distribution of y respectively. So how will you verify? If you add this fxi, it should give 1. Even gyj, it also gives 1. Now, how to find the covariance of xy? That is E of xy minus Ex into Ey, or mu x into mu y, one at the same. But what is expectation of x? E of x, that is summation x into f of x, that is 2 into 1 by 4 plus 1 by 4 into 1 by 2 into 4 plus 6 into 1 by 4. So what you will get here? 1 by 2 plus here 2 plus 6 by 4 means 3 by 2. So simplify, you will get 4. Similarly, what is Ey? Ey means summation yj into gyj, right? So that is what? 1 into 1 by 2 plus 3 into 1 by 3 plus 9 into 1 by 6. So at the end you will get 1 by 2 plus 1 plus 9 by 6. 9 by 6 means what? 3 by 2. 3 by 2 plus 1 by 2 means 4 by 2, that means 2. 2 plus 1 means 3. So at the end we will get 3. What is E of xy? That is summation xi yj into jij, right? So x1 y1 into j11 plus x1 y2 into j12 plus x1 y into j13, like that. Similarly, you have to continue. It is same as your previous sum. Just only the thing is here 3 by 3 concept given. So what you will get? 2 into 1 into 1 by 8 plus 2 into 3 into 1 by 24 plus 2 into 9 into 1 by 12. Similarly, next go to this one, j to 1, that is what? X2 y1 j2 1. So 4 into 1 into 1 by 4. Similarly, x2 y2 into j2 2, 4 into 3 into 1 by 4 plus x2 y3 into j2 3. So what you will get? 4 into 9 into 0. Next, plus x3 y1 into j3 1. So 6 into 1 into 1 by 8 plus x3 y2 into j3 2, that is 6 into 3 into 1 by 24 plus x3 y3 j3 3. So 6 into 9 into 1 by 12. Now simplify, you will get e of xy equal to 12. So what is covariance of xy? Exy minus ex into ey. So 12 minus 4 into 3, that is 12 minus 12 is 0. So the covariance of xy equal to what? 0. So what is the correlation of xy? Correlation of xy is nothing but rho of xy, that is nothing but covariance xy divided by sigma x into sigma y. But what is covariance of xy? 0. Sigma x is 4, sigma y is 3. Whatever the term here, what you will get? 0 by any value, that is 0. So here we are getting what? Complete this value is 0, right? Now the joint probability distribution of two discrete random variables x and y is given by, see here, f of xy equal to k into 2x plus y, where x and y are integers such that x lies between 0 to 2 and y lies between 0 to 3. That means x takes the values what? 0, 1, 2. Y takes the values what? 0, 1, 2, 3. Equality given here, right? So less than or equal to means that 3 also included, even 0 also included. Find the value of the constant k. Then find the marginal probability distribution of x and y. And last, show that the random variables x and y are dependent. Okay, now first you have to find what are x values, that means what x values takes, x1, x2, x3 like that. Similarly, what y values takes. After that, with the help of this given condition, you have to construct a table. That is very, very important. So here capital X takes the values, here 0, 1, 2, because here x value takes the value from 0, 1, 2. Even y 0, 1, 2, 3. Now construct a joint probability distribution, that is f of xy equal to what? K into 2x plus y. The joint probability distribution table is what? See here, x value you have to write 0, 1, 2 and sum. Y values are what? 0, 1, 2, 3 and it's here sum. Okay, now just replace x and y values here. See x is 0, y is 0, then what is the f of xy? K into 0 plus 0, that is 0. Now x is 0, y 1. So what? X 0, y 1 into k. So 0 plus 1 into k means k here, right? Next, x 0, y 2. Replace here. What you will get? F of 0, comma 2 like this. So k into 0 plus 2. So 2k, right? Right here. Next, x 0, y 3. That is what? K into 0 plus 3. That is what? 3k. Next, add this 0 plus k plus 2k plus 3k, that is 6k is the sum. Similarly, put x equal to 1, y equal to 0. What you will get? F of 1 comma 0 equal to k into 2 into 1 plus 0. So 2k right here. Next, x1, y1. So what you will get? F of 1 comma 1, that is k into 2 plus 1. So 3 into k. Next, put x1, y2. So what you will get? F of 1 comma 2. So what? K into 2 into 1 plus 2. So 2 plus 2, 4. 4 into k, that is 4k. Next, x1, y3. So what you will get? 2 plus 3, that is 5. 5 into k, that is f of 1, 3. So 5k. Now add this 2k plus 3k plus 4k plus 5k. So what you will get? 2 plus 3 is 5. 5 plus 5 is 10. 10 plus 4 is 14k. Similarly, find it for x value to y value 0. So f of 2 comma 0, that is equal to k into 2 into 2 plus 0, that is 4k. Next, x to y1, that is what? F of 2 comma 1, k into 2 into 2 plus 1, that is 5k. Next, f of 2 comma 2, that is k into 2 into 2 plus 2, that is 4 plus 2, that is 6. 6 into k, that is 6k. Next, last one, f of 2 comma 3, that is what? K into 2 into 2 plus 3, that is 4 plus 3 is 7. 7 into k is 7k. Now add this row wise, 4k plus 5k plus 6k plus 7k, that is 11 plus 4, 15. 15 plus 7, 22k. Now add each column wise. Row wise already we have done. Now go through with the column wise. So 0 plus 2k plus 4k is 6k, k plus 3k plus 5k is 9k, 2k plus 4k plus 6k is 12k, 3k plus 5k plus 7k is 15k. Now here if you add 6 plus 14 plus 22, what you will get? 42k, right? Similarly, here 6k plus 9k plus 12k plus 15k, again we will get 42k. But we have now for the distribution, if the sum 42k, it should be equal to 1. We want equal to 1, right? But here k is unknown quantity. We are using this concept to find the value of k. So 42k equal to 1. So what is the value of k? K equal to 1 by 42, right? Now after finding this k value, just replace it in marginal distribution concept. That is, what is the x value? 0, 1, 2, y value 0, 1, 2, 3. According to this, you have to compute right here. So what are the marginal probability distribution of x and y? See, x values are 0, 1, 2. What is fxy? Just replace here. What is f of xy? Here, see, 6 by 42. And next, fx2 is 14 by 42. fx3 is here 22 by 42. So simplify 6 by 42 means 1 by 7. Then 14 by 42 means that only we have written here. See here. 1 by 7, next 1 by 3, next 11 by 21. Similarly, what is the marginal distribution of yj? See, y values takes 0, 1, 2, 3. What are y values? 6 by 42, because k is 1 by 42, right? 6 by 42, 9 by 42, 12 by 42, 15 by 42. Compute. So 1 by 7, 3 by 14, 2 by 7, 5 by 14. Now we have to check whether it is dependent or not, right? Now here fxi into gyj, it should be equal to jij, right? Check any one. See here, fx1 into gy1, I will compute 1 by 7 into 1 by 7, that is 1 by 49. But what is actually j11 we got according to the table? See here, 0. J11 is 0. Okay, let us continue with the some more. What is J2? 2. For example, J22, this one, 3k. 3k means 3 by 42. Check whether we are getting the same J22. That means what? fx2 into gy2. So 1 by 3 into 3 by 14. So what we have to get? So 1 by 3 into 3 by 14 means 1 by 14 is the answer. But J22, what we got? J22 is here 3k, that is 3 by 42. So obviously it is not matching. So if fxi into gyj, which is not equal to jij, we can say that they are not independent, or we can say it as instead of not independent, you can write it as dependent. Okay, so this is very important concept, because here k is unknown. We are going to find k value, then we are going to find the remaining terms, right? That is marginal distribution and all, right? Now let us move to one more example. Okay, here previous example, here we need to find same example whatever we have given earlier. In this case, you have to find e of x, e of y, e of xy, e of x square, e of y square, sigma x, sigma y. Okay, now we have already the same table. Just you need to compute expectation of x, expectation of y, expectation of xy, and expectation of x square, expectation of y square, and sigma x and sigma y. Now, what is the table we have discussed already? For the previous table itself, we need to find expectation and all, right? See here, x into fx, 0 into 1 by 7, 0, plus 1 into 1 by 3, that is 1 by 3, 2 into 11 by 21, so 22 by 21. Now simplify 1 by 3 plus 22 by 21, what you will get here? See, Simplify, you will get 29 by 21 after simplification, right? Now similarly, here you have to find it for e of y also. Similarly, you need to find it for, see, either you can take this one or you can take this one also, it is left to you. Now e of y is what? 0 into 1 by 7 plus 1 into 3 by 14 plus 2 into 2 by 7 plus 3 into 5 by 14. So what you will get? 0 plus 3 by 14 plus 4 by 7 plus 15 by 14. After simplification you will get e of y is 13 by 7. Similarly, how to find e of xy? Again same formula, summation of xi yj into jij, right? So what? x1 y1 into j11 plus x1 y2 into j12, the same formula. So what you will get here? x1 y1 into j11. See, x1, this one into y1, x1 y1 into j11, right? Now what is j11 here? See, already we have given j11 is 0, j12 is k is nothing but 1 by 42. Just you need to substitute here back. That's it. So what you will get here? 0 plus 3 by 42 plus 8 by 42 plus 15 by 42. Take the LCM. Here denominator is common 42. So 15 plus 8 plus 3. What you will get? 26 by 42. Plus here 0 plus 10 by 42 plus 24 by 42 plus 42 by 42. So what you will get here? 24 plus 10, that is 34. 34 plus 42. So what? 76. So finally if you add, denominator is same 42. 102 divided by 42, that is equal to 17 by 7. Now we have e of x answer, e of y answer, e of xy answer. Now can you find here next e of x square? What is meant by e of x square? Summation x square fx. X square is 0. 0 into 6 by 42 plus what? X square, 1 square. 1 square into 14 by 42 plus 2 square into 22 by 42 plus or equal to what you will get, that you need to find. See here. So 102 by 42, that is nothing but 17 by 7, right? Now e of y square. What is e of y square? Y square into g of yj. So just to square and simplify. See here, y square is what? 0 square into 1 by 7 plus 1 square into 3 by 14 plus 2 square into 2 by 7 plus 3 square into 5 by 14. So what you will get here? See, simplify. You will get 0 plus 1 into 9 by 42 plus 4 into 12 by 42 plus 9 into 15 by 42. That is, denominator is 42 is common. Now 12 into 4 plus 9 plus 9 into 15, you will get 192 by 42. That is 32 by 7. Now you need to calculate what? Sigma x square. See here, we need to find sigma x square because we want sigma x and sigma y. First you have to find sigma x square, sigma y square, then take its square root. So what is sigma x square? Sigma x square is nothing but variance, that is e of x square minus ex whole square, right? Variance, e of x square is what? 17 by 7 minus e of x. E of x already we obtained, or mu x. See here, 29 by 21, its a whole square. That is 17 by 7 minus 29 by 21 whole square, we will get 230 divided by 441. So what is its square root? That means standard deviation we need to find. Standard deviation is nothing but what? Square root of variance, that is sigma x equal to root 230 divided by 21. Similarly, what is sigma y square? E of y square minus mu y whole square, or E of y whole square. That is 32 by 7 minus 39 by 21 whole square, because mu y is nothing but expectation of y. See here, what we obtained, E of y 13 by 7. Now it's a whole square. You will get, see, 13 by 7 means nothing but 39 by 21 at the same. It's a whole square, that is 495 by 441. What is its square root? Sigma y equal to root 495 by root 441, that is we'll get 21. Now after simplification, sigma x equal to what? The simplified form is 0.72 and sigma y is 1.06. So these are the standard deviation for the given problem. See here they have given k in the beginning step, they have given in terms of k. For the same problem they have extended in the next one, that is expectation of x and all, right? Now next move to the one more example. See here, a fair coin is tossed thrice. The random variables x and y are defined as follows. X equal to 0 or 1 according as head or tail occurs on the first toss. Okay. And y represent only the number of heads. Here, see once again, a fair coin is tossed thrice. 3 times they tossed. So how many combinations possible? You have to think about that first. Okay, the random variable x and y are defined as follows. See, x takes either 0 or 1. So according as what? Head comes first, then 0. Tail comes first, then 1. Like that. And y represent what? Number of heads only. Now, first one, determine the distribution of x and y. Determine the joint distribution of x and y. Obtain the expectation of xy as well as standard deviations of x and y, and compute covariance and correlation of x and y. See, here you should compute, first thing is the table, that is what is x, what is y, what is probability distribution first, that is nothing but because of this head and tail we have to construct a table first. That is very important. After that you can manage rest of thing as previous step. Now first, what are the possibilities if you throw a coin thrice? See, first head, next to tail, that is one possibility. Next head, tail, tail, head, tail, head, tail, head, head, tail, tail, head, tail, 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 head, head, head. So total 8 possibilities there, right? See here, the sample space S and association of random variables x and y is given by the following table. So what is S represent here? Sample space. Now what are the total possibilities? If you throw a coin thrice, there are these many possibilities. One is all are head. First 2 head, next tail. First head, next tail, again head. Again first head, last 2 tails. Then first tail, rest all 2 tails. Tail, head, tail, 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 head, and tail, tail, tail. So these are the 8 possibilities. And what they have given, according to that you have to mention what is x and y. X represent what? 0 or 1 according as head or tail occurs on the first toss. Say that means head occurs first, then you have to mention 0. Tail occurs first, then you have to mention 1. And what is y? Y represent number of head. See here, first head occurs means you have to mention 0 for x. So 0, here also 0, here also 0, here also 0. When the tail appears first, then what is x represent? 1, here also 1, here also 1, here also 1. But what y represent? Y represent what? Number of heads. So here how many heads? 1, 2, 3. So how many heads here? 2, here 2, here 1, here 2, here 1, here 1, here no head, that's why 0. So what is x values totally? X values are 0 and 1 only, right? X. So probability distribution of x and y is defined as follows. Capital X, that is xi, this represent either 0 or 1, only 2 possibility. What about y here? It will take 0, 1, 2 as well as 3. So how many possibilities? Y represent 0, 1, 2, 3. Now we need to find the probability for each and every case. When x is 0, see probability of x is 0. How many times? Out of 8, there are 4 times 0. So 4 by 8. So what is the probability of getting x equal to 0? It is 1 by 2. Similarly, what is probability of getting this one? X is 1. 1, 2, 3, 4 out of 8 outcomes. So what is P of x equal to 1? That is 4 by 8, again that is 1 by 2. So these are the marginal distribution for what? P of x. Now what about y? Similarly, what is probability of getting y 0? How many times? 1 time out of 8. So 1 by 8. Similarly, what is probability of getting 1 here? y1, 1, 2, 3 times. So 3 by 8. What is probability of getting 2 from the table? 1, 2, 3. So 3 by 8 again. What is probability of getting 3? How many times from this table? 3. Only 1 time. So 1 by 8. So these are the possibility of getting 0, 1, 2, 3 for y. Similarly, 0 and 1. Probability of getting 0 and 1 for x, that is 1 by 2 and 1 by 2. See, if you add this 1 by 2 plus 1 by 2, you will get 1. Again, 1 by 8 plus 3 by 8 plus 3 by 8 plus 1 by 8. See, add this all, 8 by 8, that is equal to 1. So, your marginal distribution is proper. Or you can mention it in the table also. See here, table. See, thus we have the following probability distribution of x and y, or we can say it as marginal distribution of x and y. So how will you write? That is xi represent what? 0 and 1. And what is f of xi? 1 by 2, 1 by 2. If you add, you will get 1. Similarly, what are yj? 0, 1, 2, 3. And gyj already we have discussed. That is 1 by 8, 3 by 8, 3 by 8, 1 by 8. Now after this, we have to compute what? Joint probability distribution, right? What is Jij? That is, we have to find fxi into gy. So 1 by 2 into 1 by 8, similarly 1 by 2 into 3 by 8, 1 by 2 into 3 by 8, like that you have to find. Now what is here? X1 equal to 0, x2 equal to 1, y1 equal to 0, y2 equal to 2, y1 equal to 0, y1 equal to, y2 equal to 1, y3 equal to 2, y4 equal to 3. Now what is J11? Now find out J11. Similarly, J12, J13. See here, computation is given here. Now, what is here J11? J11 means P of x0, y0. Here both are 0, right? Now, what is J12? That is P of x0, y1, that is 1 by 8. Corresponding to the outcome HTT, right? What is J13? P of x0, y2, that is 2 by 8. That is nothing but 1 by 4, right? Outcomes are what? HHT and HTH. What is J14? J14. 1 means what here? X0. 4 means what? Y3. So, P of x0, y3, when it is possible? That is 1 by 8, right? See here. See. x0, y, x0, P of x0, y2, that is 2 by 8. So, 1 by 4. What are the possibility? HHT and HTH. HHT and, see here. HHT and HTH, right? So, what are the possibility here? We have to simplify. What we will get here? After simplification, see here, 1 by 4. Next, what is J14? That is P of x0 and y3, that is 1 by 8. Outcome is what? Only 1 here, that is HHH. Next, J21 is nothing but here P of x equal to 1, because for the x value, x equal to 0 is here 1, and here x equal to 1 means J2, and J21 is nothing but y equal to 0. So 1 by 8. Outcome is what here? All the tails, that is TTT. Next, J22 is nothing but P of probability of x equal to 1 and y equal to 1. It is possible when tail, head, tail, and tail, tail, head. That is 2 tail, 1 head possibility. That is 2 by 8. That is nothing but 1 by 4. Next, J23. J23 means what? Probability of x equal to 1 and y equal to 2. This is possible when first one tail, next two are heads. That is first one tail, next two head. So this is possible only when here its joint probability is 1 by 8. J24, that means P of x equal to 1, y equal to 3. So which is nothing but 0, since the outcome is impossible, right? See here, x equal to 1 and y equal to 3. X equal to 1 represent what here? X equal to 0 represent head comes first. Head here tail comes first, and y equal to 3. This is not possible case, because y represent number of tail. Okay, now here we need to find it for. See, this can be represented in the table as follows. See here, table we have given, that is the required joint probability distribution of x and y is as follows. So x represent what? 0 and 1. Y represent what? 0, 1, 2, 3, right? And it's sum row and column sum. Now here J11 is 0, J12 is 1 by 8, J13 is 1 by 4, J14 is 1 by 8. Similarly, J21 is 1 by 8, J22 is 1 by 4, J23 is 1 by 8, J24 is J23 is 0. Now add column wise. So 0 plus 1 by 8 is 1 by 8. 1 by 8 plus 1 by 4. Take LCM. 8 is the LCM. 2 plus 1, that is 3. Now 3 by 8. Now again 1 by 4 plus 1 by 8 is 3 by 8. 1 by 8 plus 0 is 1 by 8. So these are the what? Marginal distribution of y. And similarly here add this. 1 by 8 plus 1 by 4 plus 1 by 8, that is 2 by 8, that is 1 by 4. 1 by 4 plus 1 by 4, that is 2 by 4, that is nothing but 1 by 2. Again add this 1 by 8 plus 1 by 4 plus 1 by 8, that is 1 by 2. Now add this 1 by 2 plus 1 by 2 is 1. Again 1 by 8 plus 3 by 8 plus 3 by 8 plus 1 by 8, that is also 1. Now find the expectation of x, that is what? E of x, which is equal to summation x fx, right? Now what is summation x into fx? So we are getting what? X is 0. Fx is what? We have already done here. That is 1 by 2. See here. 0 into 1 by 2 plus 1 into 1 by 2. That is what? 0 plus 1 by 2. That is 1 by 2. So expectation of x or mu of x equal to 1 by 2. Similarly, find mu y or e of y. That is summation yj gyj, right? So yj is what? 0, 1, 2, 3. What is gyj? 1 by 8, 3 by 8, 3 by 8, 1 by 8. So 0 into 1 by 8 plus 1 into 3 by 8 plus 2 into 3 by 8 plus 3 into 1 by 8. So what you will get here? Simplify. You will get finally 3 by 2. Now find out expectation of xy, that is E of xy, which is nothing but here summation xiyj into jij. So x1 y1 j11 plus x1 y2 j12, like that you have to compute everything. So what you will get here at the end? You will get 1 by 2. Okay, so how many possibilities? See here, x1 j, here j11 j12 j13 j14. So x1 y1 j11 plus x1 y2 j12 plus x1 y3 j13 plus x1 y4 j14. Similarly plus x2 y1 j21 plus x2 y2 j22 plus x2 y3 j23 plus x2 y4 j24, right? Now after computation you will get its answer 1 by 2. Now we need to find what? Sigma x and sigma y, right? That is standard deviation of x and standard deviation of y we need to find. For that we can find sigma x square, that is variance. What is sigma x square? E of x square minus E of x whole square. Similarly sigma y square is E of y square minus sigma y mu y whole square, right? Or E of y whole square. That is nothing but what? E of x square you need to find, that is summation x square fx. So what you will get here? Summation x square fx. X square is 0. 0 square into 1 by 2 is 0. Plus 1 square into 1 by 2 means 1 by 2. So E of x square is nothing but 1 by 2. Right? See here. 1 by 2 minus mu of x whole square, that is E of x whole square. E of x already we obtained 1 by 2. So what? 1 by 2 minus 1 by 2 whole square, that is 1 by 2 minus 1 by 4, that is 1 by 4. Now what is sigma y square? That is E of y square minus mu y square. But what is E of y square? See here, 0 square into 1 by 8 plus 1 square into 3 by 8 plus 2 square into 3 by 8 plus 3 square into 1 by 8. So after simplifying you will get it is in the form of, see, 3 by 8 plus 3 by 2 plus 9 by 8 minus E of y whole square. But E of y is 3 by 2. So its whole square is nothing but 9 by 4. So if you simplify this 3 minus 9 by 4, that is 3 by 4. Now take the LCM. What is sigma x? Square root of 1 by 4, that is 1 by 2. What is square root of sigma y square? That is root 3 by 2. Now we need to find covariance and correlation, right? Now what is covariance of xy? That is E of xy minus Ex into Ey. What is E of xy? We have found already. E of xy is nothing but 1 by 2. And Ex is nothing but what? Previous slide. Ex is nothing but 1 by 2. And what is E of y? 3 by 2. So just use the formula here. So E of xy, that is 1 by 2 minus here 3 by 4, which is equal to minus 1 by 4, right? Now, what is rank correlation or row of xy, correlation of xy, that is nothing but covariance of xy by sigma x into sigma y. So, covariance of xy is minus 1 by 4 and sigma x is root 3 by 4. Root sigma x into sigma y is like this we will get. After simplifying this 4 get cancelled, minus 1 by 3 is the answer. So what is covariance of xy? Minus 1 by 4 and correlation of xy, that is rho xy, which is equal to minus 1 by root 3. Okay, now next let us move to the one more problem. See, a fair coin is tossed thrice. The random variables x and y are defined as follows. See, x takes the values 0 or 1 according as head or tail occurs on the first toss, and y equal to number of heads, right? Now, compute, see here, p of x equal to 1, y equal to 2, p of x greater than or equal to 1, y less than or equal to 2, p of x less than or equal to 1, y less than or equal to 2, p of x plus y greater than or equal to 2. Already we have discussed about this, right? Because when a fair coin toss thrice, there are total 2 power 3, that is 2 power 3 means 8 possibilities, that already we have discussed in the previous example, right? Now, here x takes the values what? 0 and 1, and y takes the values what? 0, 1, 2, 3. That we have done in previous two problems, same problem. Just here the condition is different they have given, right? Now, what is J11? We have already obtained J11, J12, J13, J14, similarly J21, J22, J23, J24. If you want, you can see here in the previous 2-3 slides, the same thing we have explained. See, this only the explanation, whatever we have given here. See here, this same problem, sixth sum, this problem only we have continued now. Okay, now the condition only different. Now let us try with this. See here, now first condition, what is given? P of x equal to 1, y equal to 2. What is that? X equal to 1, y equal to 2 means P of x to y3. X to y3 means J23. But what is J23? We have got 1 by 8. Just you write that one. That's it. So, J23 is here 1 by 8. Next, P of x greater than or equal to 1, y less than or equal to 2. What is the meaning? X greater than or equal to 1 means what? Here maximum 1 only. There is no more than 1. Because x takes 0 and 1 only. But y 0, 1, 2 is there. So, how many possible combinations are there? X greater than or equal to 1 means 1 only here, because x takes the value 0 and 1. But greater than or equal to 1 means only one possibility. So, 1, y0, x1, y1, x1, y2. So, these are the three possibilities. So, what? x1, y0 means x2, y1, and here x2, y2, this is x2, y3. So, what? We have to add all the combinations. That is what? J21 plus J22 plus J23. But what is J21 plus J22 plus J23? See here, 1 by 8 plus 1 by 4 plus 1 by 8. Now simplify, you will get 1 by 2. Okay. So therefore, P of x greater than or equal to 1, y less than or equal to 2, its answer we will get 1 by 2. Now what about next one, third case? That is P of x less than or equal to 1, y less than or equal to 2 given. So that what is the x and y value takes here? Less than or equal to 1 means 0 and 1. So there are two possibilities. Here less than or equal to means 0, 1, 2. So these are the three possibilities. So how many possible combination? When x0, y0 possibility, x0, y1, x0, y2. So these three combination for 0. Next, take the value x1 and y vary. x1, y0, x1, y1, x1, y2. So these are 6 possible combination. So what is this x0 and y0 when? x1, y1 case. x0, y1 when? x1, y2 case. So x1, y1, x1, y2, x1, y3. Next, x2, y1, x2, y2, x2, y3. So what are the possibilities? J11 plus J12 plus J13 plus J21 plus J22 plus J23. Now add this J21, say here everything is available here. Just substitute and add. You will get what? see here 7 by 8 is the answer. Therefore, p of x less than or equal to 1, y less than or equal to 2, that is nothing but 7 by 8. Now what about the last condition? P of x plus y greater than or equal to 2. So x plus y greater than or equal to 2 means what is the possibility here? If you add x and y value, it should cross 2 or it should be equal to 2, its meaning, right? So x and y takes the value what? When it is possible? When x0, y2, x0, y3, or y x1, y1, x1, y2, x1, y3. So these are the possibility. So when x0, y2, sum is 2. x0, y3, sum is 3. x1, y1, sum is 2. x1, y2, sum is 3. Similarly, x1, y3, sum is 4. Now, what are the possibilities? This we are representing x1, y3. Here x1, y4, x2, y2. This is x2, y3 and x2, y4. Now, what is p of x plus y greater than or equal to 2? j13 plus j14 plus j22 plus j23 plus j24. Now add this value 1 by 4 plus 1 by 8 plus 1 by 4 plus 1 by 8 plus 0. If you add, you will get 3 by 4 is the answer. So what is probability of x plus y greater than or equal to 2? That is 3 by 4, right? Now next let us move to the last one, sum under joint probability. So here all varieties of problems we have done. Okay. See here, if x and y are independent random variables, prove the following results. First one, E of xy equal to Ex into Ey. Next, covariance of xy equal to 0 and sigma x plus y whole square equal to sigma x square plus sigma y square. That is, variance of x plus y whole square is nothing but variance of x square plus variance of y square. So what is E of xy? We have the formula summation xi yj into jij, right? Now since they have mentioned already it is independent random variable, that means it will satisfies the definition of independency, that is jij is nothing but fxi into gyj. So what is E of xy? Summation xi yj into fxi gyj, right? Now split here, that is summation xi fxi summation yj gyj. So that is nothing but this is E of x and this is E of y. See once again, E of xy, we need to prove Ex into Ey. Now what is the definition of E of xy? Summation xi yj into jij. But what is jij? That is fxi into gyj, because they have already mentioned x and y are independent. Because of the definition of independent random variable, we can write jij in the form of product of these functions. So here instead of jij, we are mentioning fxi into gyj. Now split xi and fxi term one side and yj and gyj other side. So what we will get here? Expectation of x into expectation of y, right? So this is nothing but here E of x and E of y. So therefore expectation of xy is E of x into E of y. What about next one? Covariance of xy. What is the definition of covariance of xy? Exy minus Ex into Ey or mu x into mu y. So E of xy minus Ex into Ey. But what is E of xy? In the previous case we have discussed, that is Ex into Ey only, right? Because of independent random variable. E of xy is nothing but Ex into Ey. So same thing if you apply here, Ex into Ey minus Ex into Ey, which is equal to 0. So what is covariance of xy? That is 0. Now what they asked in the next problem? Variance of x plus y whole square. What is the definition of variance of x plus y whole square? Just you apply the definition of this E of x plus y. That is nothing but summation of here what? X plus y, or summation, just you apply sigma x square definition is what? Summation E of x square minus Ex whole square. Ex square minus E of x whole square. Same thing you have to apply. So xi plus yj whole square into jij minus E of x plus y whole square, or here mu of x plus y whole square. Or can you split here a plus b whole square form? So what is a plus b whole square? A square plus b square plus 2ab, right? Use that. So here what happens? Xi square jij plus yi square jij plus 2xi yj jij. But summation everywhere in terms of I and j, and minus mu x plus y whole square. But what is this? X square jij is nothing but expectation of x square. So summation xi square jij can be written as what? Summation xi square jij can be written in the form of fxi into gyj because of independency we have already discussed. Similarly, how will you write yj square into this? Similarly, this can be written as summation yj square into fxi into gyj. This also can be written in the form same. Or can we write this is same as summation gyj into summation xi square fxi, one at the same. But what is summation gyj? Which is equal to 1. Therefore, summation xi square jij equal to summation xi square fxi, because gyj is equal to 1, so it will become only xi square fxi. Right? Now, which is equal to what? Similarly, summation yj square jij is nothing but what? The summation yj square gyj, because again fxi is 1. Or summation xi yj into jij is nothing but summation xi fxi into summation yj gyj, that is expectation of x into expectation of y. Now similarly, how will you find expectation of x plus y? Apply the same formula, summation xi plus yj into jij, or xi plus yj into what is jij formula, fxi into gyj. Now simplify, that is mu of x plus y equal to e of x plus y, that is equal to summation xi fxi plus yj gyj. But what is gyj? Already we have done, it is equal to 1, and summation fxi also 1. So because of this here, we can write it in the form of e of x plus e of y. Okay. Now last, using all these in the RHS of the expression. So what is summation sigma x plus y whole square? That is summation xi square fxi plus 2 times expectation of x expectation of y plus summation yj square gyj minus e of x plus e of y whole square, or which is nothing but e of x square plus 2 into expectation of x expectation of y. This is nothing but expectation of y square, and this is nothing but just you simplify a plus b whole square, so a square, so e of x whole square minus e of y whole square minus 2ex into e of y. Now plus 2ex minus this one cancel, what remains here? E of x square minus e of x whole square plus e of y square minus e of y whole square. But what is this definition? Sigma x square, or variance of x square. So what? This is variance of y square, that is sigma x plus y whole square equal to sigma x square plus sigma y square. Okay. Here, those are finding difficulty with this last sum, you can leave, but remaining all you should practice properly in joint probability. That is very, very, very important concepts. Okay. Thank you.